Assalamualaikum and a good day to all panelists. In this session, I will share to all of you about my final year project with the title Electromyographic Muscle Analysis of Counterbelly Arm Sling for Exercise for Rehabilitation Malaysia Population. Before I go through with my presentation today, let me introduce myself. My name is Muhammad Akmar bin Ruslan and my supervisor is Puan Ruzi Haryati binti Hambali. Now we go to introduction. According to Watson 2008, hemiplegia is defined as a paralysis on one side of the body caused by brain damage, while hemiparesis is a weakness or partial paralysis on one side of the body caused by brain damage, while the electromyography (EMG) is used to detect muscle function or muscle activity through electrical stimulation. So, what is the problem? Hemiparesis patient facing trouble in performing exercise during the therapy session and daily activities. Some patients were able to cure, but some need rehabilitation. However, effectiveness of the device performance not yet confirmed. And if this EMG tool fully help in solving to improving the muscle activities. The objective of this project is first to investigate muscle activity of normal people without counterbelly arm sling. Second is to evaluate the effect of muscle using surface electromyography device. And the last one is to determine the effectiveness of using counterbelly arm sling for muscle to improvement and time to fatigue for hemiparesis patient. The scope of the project is to analyze the muscle activity of hemiparesis patients when using the device for rehabilitation in Malaysia population. The scope is getting to the respondent to that consist of normal people perform muscle testing activity using EMG in order to evaluate the effect of muscle strength to the patient and analyze all the result of him. This is a literature review for previous research. Baharudin et al. 2018, the EMG signal was as an input and then the data was acquired by interface with MATRIC software. And Wei J. Huang et al. 2018 to increase EMG activity of LOT and to improve strength of elbow extension. For methodology, on the left show that the flowchart of the research. We start with identify the problem, then find the source such as get a respondent and then continue with conduct pilot test. EMG testing in two conditions without and with assistive device, and lastly analyze the data. On the right, flow how we can conduct the experiment. Firstly, attach EMG sensor to the normal people or patient, then run the experiment with or without the assistive device, and after that run the experiment based on state activity, which is forearm extension, and experiment is conducted within the time frame 50 seconds and analyze the data. Standard SOP for EMG will apply to respondent as agreement to do this experiment. First, respondent were asked to dress loosely and cooperate during experiment. Experiment will take 1 hour or more than for one respondent, depend on how many experiment going to do. Respondent also were asked to allow to be safe to perform this experiment. The figure show daily stricno electromyography EMG, the tool that we use to perform this experiment. Skin preparation is needed before run the experiment. The quality of EMG measurement depend on a proper skin preparation. So firstly, remove the hair on the skin. This is needed to improve an adhesion of the electrode. And the second is cleaning the skin. There are three methods can use for this, which is use special abrasive, use sandpaper, or use alcohol. And for this research, we use sandpaper because easy to get and apply. And the figure show the spot of the EMG sensor on human body. This is one of the important part before start experiment. is to identify the right muscle for this exercise. So there are three types of muscle involved for forearm extension, consist of tricep brachii, deltoid, and anconeus muscle. This is the information of subject consists of three subjects with average age 25 until 27 years old, and all subject is normal people. A figure show how exercise will conduct. For result and discussion, this is how the data looks like after all procedure and experiment done. On the left show the result of muscle activity without assistive device, while on the right show the result of muscle activity with assistive device. Both of the results representing the average RMS value of tricep brachii of normal people. The subject will give 30 minutes to rest their muscle before start experiment. This is to make sure the muscle in rest condition before start experiment. 30 minutes is more than enough for normal people. As we can see for muscle without using device, the noise show the almost similar pattern for all three subjects. The RMS value for all subjects is recorded below 5 microvolt. The average baseline noise of relaxed muscle not higher than 3 until 5 microvolt. And on the right show RMS value tricep brachii muscle while using assistive device. If we can see properly, there is an increase made in muscle activity when performing activity while wearing assistive device. So this is the table for average RMS for both results. So we can see that for subject 1 from 0.00015 volt increase to 0.00072 volt. For subject 2 from 0.00012 to 0.00021, and for the subject 3 from 0.00018 to 0.0005. Next, this is the data for muscle activity without and with assistive device for deltoid muscle. So the table shows there is increasing average RMS value for subject 1 from 0.00011 to 0.00116. For subject 2 from 0.00012 to 0.00029. And for subject 3 from 0.00016 to 0.0051 volt. This is the last type of muscle that we test without assistive device and with assistive device. The raw EMG baseline noise depends on many factors, especially the quality of the EMG amplifier, the environment noise, and the quality of the given detection condition. Based on both graphs, also can see the increasing RMS value after using device for subject 1, 2, and 3. Based on the graph above, here it can be stated that after using this tool, it is proven that there are changes in the muscle due to the more force exerted on the muscle to perform the activity. This is because the device has its own level load to be pushed by the user according to the strength of the user. This is bar graph of comparison tricep brachii muscle for both exercise, which is forearm extension without using assistive device and with assistive device. It explains the difference of average RMS value between normal people without using assistive device and using assistive device. The pink bar representing without assistive device, while the blue bar representing with device. For tricep brachii muscle subject number 1, the average RMS value increased by 78%. For subject number 2, increased by 43%, and subject 3 increased by 65%. The next comparison is for deltoid muscle. The percentage increase for subject 1, 90.5%. Muscle expansion increased 60.5% for subject 2 and 68% for subject 3. Lastly, for anconeus muscle, this is comparison bar graph anconeus muscle of normal people, where each subject increased 79.4% for subject 1, 75.3% for subject 2, and 77.5% for subject 3. The percentage value between without and using device depend on how the load applied toward subject. There are many levels of load available on this existing device. The load used depends on the strength of the user to push their arm when using this device. Based on the graph, we can see that there is significant increase in terms of muscle expansion through the value of RMS. Almost all the muscle type involved experience an increase of more than 50% from their original state. This is proven to show that this tool is very helpful to user in the process of muscle recovery, especially for hemiparesis patients. Conclusion of the research is the muscle activity for human body can be defined by using a tool, which is ENG. The final data we get after experiment prove that this existing device gives effect to the human muscle in order to increase muscle expansion. And we conclude that effectiveness of existing device managed to regain muscle activity for rehabilitation process. The recommendation for future research is analyze muscle activity using EMG signal with various types of exercise such as shoulder motion, vertical and horizontal flexion. Increase the number of respondents consists of male and female for age from young to old respondents in order to gain more accurate results. I think all my data is straightforward and easy to understand. If all panel have any question, can ask me. That's all from me. Thank you.